Welcome to EDU World Space.
So in this question, we are given a thin walled cylinder, right? And this in cylinder, it has an inner radius r, right? And its thickness is t, right? And that is subjected to pressure p. Right now it says that the material constants are E and epsilon. We are required to determine the strains in the cylinder, right? The strains in the circumferential and longitudinal directions, right? That is sigma sub 1, sorry, not sigma, it's epsilon, right? So it's uh, epsilon sub 1 and epsilon sub 2, right? Now it says that using these results, calculate the increase both in the diameter. Then we need to calculate the increase in diameter and length of a steel pressure vessel. Right now, it tells us that the vessel is made of steel material, right? And it says that the internal gauge has a pressure of 15 megapascals, right? It says that the vessel is the length of vessel is 3 meter long, right? And it has an inner radius of 0.5 meter, right? And it says that it has a thickness of 10 millimeter, right? And it says that its elasticity is equal to 200 gigapascals and its epsilon is equal to zero point 0.3, right? So let's take a look at its um, solution. Now we are told by the solution for this question, it's a little bit lengthy but it's very simple, right? So it says that like according to this question, right, we are dealing with a thin walled vessel, as we discussed above, right? And therefore it means that we can use chapter number 8, right? Because it deals with thin walled vessels theory. Right now, what we are going to do over here is that we are going to use equation 8.1 and equation 8.2, right? So equation 8.1 is that sigma sub 1 is equal to P times R divided by T, and equation 8.2 is that sigma sub 2 is equal to P times R divided by 2T, right? So 2D, right? Now what we are going to do over here is that we are going to calculate the values of these stresses, right? And just plug in the given values that we have. So we get that sigma sub 1 is equal to 200 megapascals and sigma sub 2 is equal to 100 megapascals. Now what we are going to do is that we are going to use the Hooke's law for two dimensions, right? So we can find the elongation the radius undergoes. So for that, Um, the first equation for the Hooke's law is that 1 epsilon sub 1 is equal to 1 divided by e square bracket stars. Since we are dealing with um, a 1 over here, so we have a sigma sub 1 negative epsilon parenthesis sigma sub 2 parenthesis close, right? And if we simplify it, we'll get that it is equal to sigma sub 1 negative epsilon times sigma sub 2 divided by the epsilon, right? Just plug in the values and we get that it is equal to 3.2 into 10 raised to power negative 3, right? Then we need to find out the value of sigma sub 2. So again, we'll write the equation, Hooke's law equation for this, and this would be sigma sub 2 negative epsilon times sigma sub 1, right? So again, just simplify it and we'll get that it is equal to sigma sub 2 negative epsilon times sigma sub 1 divided by e. Again, just plug in the values and we get that it is equal to 0.75 into 10 raised to power negative 3, right? So this gives us the ratio of the change in the perimeter divided by the perimeter, right? That is epsilon sub 1, and the ratio of the change in the length divided by length, right? So the change in perimeter can be written by del p, that is equal to del uh, times 2 pi r, right? And that is equal to 2 pi del r, right? Change, because 2 and pi, they are constant, there cannot be any change on it, so only r is the variable that is present over here. So the change can only happen in the radius, right? So now what we're going to do is that we are going to write the expression for the strain, so that is 2 pi del r divided by 2 pi r, right? Now this cancels out and we are only left with del pi r divided by r, right? So if we solve it for um, del r, so we'll get that we have del r is equal to uh, strain times the radius, right? So just plug in the values, we get that is equal to 1.6 millimeter, right? Now we need to find out the change in the length, so that would be um, epsilon sub 2 times length, right? So just plug in the values and we'll get our answer. So when you calculate it, you'll get that it is equal to 2.25 millimeter, right? And from here we can find out the change in diameter. So the change in diameter can be written as del d, that is equal to 2 del r, that is equal to 2 into 1.6, that is equal to 3.2 millimeter, right? So that concludes our problem.